There was active geology on Pluto when we saw these photographs. It was mind-blowing. Something so far from the Sun should just be a cold, dead world. We were going to collect data sets with our eyes wide open to see what was there. Pluto is hiding something that has scientists panicked and questioning everything they thought they knew. Declassified photos from the James Webb Telescope have revealed shocking details under its icy surface. What else could be lurking in the shadows beneath that frozen shell? Let us dive into this discovery that will reshape the quest for alien life forever. The frozen heart hiding something big. One of the most jaw-dropping discoveries was the possibility that Pluto's famous heart-shaped glacier, Sputnik Planitia, might be sitting atop a hidden ocean. This isn't just any ordinary ice field, it's a nitrogen glacier that stretches for over 1 million square miles. Beneath this thick layer of frozen nitrogen, researchers suspect there's a vast reservoir of liquid water. If this is true, it means Pluto has been defying expectations for billions of years. Alan Stern, the principal investigator for the New Horizons mission, believes this could be the first clue in proving that life might be possible in the most unexpected corners of the universe. Before we delve into this, it's clear that what lies beneath Pluto's icy heart is far more extraordinary than anyone ever dreamed, and this won't be the only discovery to leave you speechless. Pluto's surface tells a story of activity that no one anticipated. For a world so small and distant, it's incredibly dynamic. Vast mountain ranges made of solid water ice rise up to 4 miles high, rivaling the tallest peaks on Earth. But what's even more bizarre is how smooth some parts of Pluto's surface are. Sputnik Planitia, for instance, lacks the craters we'd expect from billions of years of asteroid impacts. Instead, it's covered in strange polygonal patterns that hint at a process called convection, where heat from below causes the ice to move and churn almost like a lava lamp. The heat source could be radioactive elements in Pluto's core breaking down over time, releasing just enough warmth to keep the ocean below from freezing solid. And it's not just the heart-shaped glacier that's confusing scientists. Pluto's entire orientation seems to have shifted, likely due to the massive weight of Sputnik Planitia's ice. This shift aligns the glacier with Pluto's largest moon, Charon, hinting at a fascinating gravitational dance between the two bodies. The cracks and faults stretching across Pluto's surface further support the idea of an internal ocean, as these features are consistent with the planet's crust flexing and moving over a liquid layer. The possibility of an ocean on Pluto raises a tantalizing question: could there be life in this frigid world? Brian Cox, a renowned physicist, suggests that if there is water, then life might not be far behind. The ocean's liquid state, insulated by a thick layer of ice, could protect any potential life forms from harsh cosmic radiation and extreme surface temperatures. While Cox is cautious, he acknowledges that even the simplest microbial life would be a groundbreaking discovery. It's not about finding complex creatures, it's about proving that life can exist in environments vastly different from Earth. Even with all this compelling evidence, proving the existence of an ocean on Pluto is no easy task. New Horizons provided just a snapshot during its flyby, capturing detailed images of only about 40% of Pluto's surface. The rest remain shrouded in uncertainty, waiting for future missions to uncover its secrets. Alan Stern and his team are already advocating for a follow-up mission, the Pluto Orbiter, which could spend years studying the dwarf planet in detail. Such a mission could confirm whether or not this hidden ocean exists and what it might mean for the potential of life. The idea that Pluto might harbor a subsurface ocean isn't just important for understanding this one dwarf planet, it's reshaping how we think about the entire solar system. If an ocean can exist here, in one of the coldest, most distant places imaginable, then where else might we find water and life? Scientists are already looking at other icy worlds like Europa and Enceladus, moons of Jupiter and Saturn, which also show signs of hidden oceans. These findings suggest that oceans might be far more common in the universe than we'd ever dared to hope. Pluto's icy surface and hidden ocean make us wonder where life might be, but could its fiery start reveal something even more surprising? A hot start that changed Pluto forever. The implications are enormous. Oceans are a critical ingredient for life as we know it, and the more places we find them, the greater the chances that life exists elsewhere. Pluto's potential ocean has forced scientists to rethink the boundaries of the habitable zone, the region around a star where conditions might support life. Traditionally, this zone was thought to end well before Pluto's orbit, but now it seems that life might be able to survive much further out, protected beneath thick layers of ice. But how did Pluto's ocean come to be? Scientists used to believe that Pluto formed slowly, accumulating ice and rock over millions of years. This gradual process would have left Pluto cold and lifeless. However, recent studies suggest a different story. Pluto might have formed quickly and violently, with massive collisions generating enough heat to create a liquid ocean that's been maintained by radioactive decay ever since. This hot start theory challenges everything we thought we knew about how icy worlds form and evolve. If Pluto did have a hot start, it means its ocean has been there for billions of years, potentially long enough for life to emerge. And Pluto isn't alone. Other dwarf planets in the Kuiper belt, like Eris and Makemake, might also have hidden oceans. This opens up a whole new frontier for exploration, as these distant worlds could hold the keys to understanding the origins of life in the universe. Despite the excitement, exploring Pluto and its neighbors is no small feat. The New Horizons mission took nearly a decade to reach Pluto, and it only spent a few hours gathering data during its flyby. A dedicated orbiter mission would take even longer, possibly over 27 years, and require significant advancements in technology. The challenges are immense, from designing spacecraft that can survive the harsh conditions to developing power sources that can last for decades. The cost is another hurdle. A mission like the proposed Pluto orbiter would likely exceed $3 billion, a hefty price tag for a single planet. But for many scientists, the potential discoveries make it worth every penny. The chance to study Pluto's ocean, its geology, and its atmosphere in detail could transform our understanding of the solar system and our place in it. As we wait for the next mission to Pluto, scientists are continuing to analyze the data from New Horizons. Every piece of information adds to the puzzle, revealing a world that's far more complex and dynamic than anyone ever imagined. Pluto's story is a reminder that even the smallest, most overlooked places can hold the biggest surprises. Whether it's an ocean beneath the ice or signs of ancient geological activity, Pluto has proven that it's a world worth exploring. In the end, the discovery of a possible ocean on Pluto is about more than just one distant world. It's about expanding our horizons and challenging our assumptions about where life can exist. It's about looking beyond the obvious and finding wonder in the most unexpected places. Pluto might be small, but its impact on science is enormous, and things are only just beginning to be uncovered. The existence of an ocean on Pluto shifts how we understand distant planets and moons, extending the possibilities for life well beyond what once seemed plausible. Even if life on Pluto is incredibly simple, its discovery would redefine the search for life in the cosmos. Scientists continue to gather evidence, and each new detail makes the idea of an active Pluto with a hidden ocean more believable. With these findings, the cold, distant dwarf planet is no longer just a frozen rock in the Kuiper belt. It's a place of wonder, potential, and a reminder of the endless surprises the universe holds. Pluto has shown us amazing things, but the rest of the solar system has even more surprises that change how we understand space. From the moon to the edge of the solar system, exploration has been a wild ride, one packed with surprises, triumphs, and lessons that have shifted how we see the universe. It's not just about planets and moons, it's about finding out where we came from, what's out there, and maybe even who or what might be sharing this cosmic playground with us. Humans have always been curious, and the stars have a way of calling to us, daring us to reach further. Let's dive into this exploration beyond the textbook stuff and see what makes it such a big deal. It kicked off in the 1950s and 60s when space became the hottest topic in the world. The moon was the first big goal, close enough to reach but far enough to feel like another world. The Soviet Union's lunar mission stole the early spotlight. Luna 2 smashed into the moon in 1959, becoming the first human-made object to make contact. A year later, Luna 3 snapped pictures of the far side of the moon, a side no human had ever seen. The US didn't take that lying down. By 1969, the Apollo program had put Neil Armstrong and Buzz Aldrin on the moon, showing the world what humans were capable of when they aimed high. But it didn't stop there. Mars became the next obsession, because let's face it, a planet that might have had or still has life is hard to ignore. The first real look came in 1965 with NASA's Mariner 4, sending back images that dashed hopes of lush Martian forests. It was dusty, barren, and looked like a giant desert. Yet we didn't give up. The Viking missions in the 70s touched down on the Martian surface, searching for any hint of life. Spoiler, they didn't find much. Fast forward to the 21st century, and rovers like Spirit, Opportunity, and Curiosity started to make Mars feel almost familiar with their selfies and discoveries. Then came Perseverance in 2021, a rover with one big job: grab samples and hold onto them until someone comes to pick them up. Venus got its fair share of attention too, though it's more of a cautionary tale. Imagine a world where it's hot enough to melt lead and the air is basically poison. That's Venus. In 1970, the Soviets managed to land Venera 7 there, even though it didn't last long in those hellish conditions. NASA's Magellan mission in the 90s went a different route, mapping the surface from orbit with radar. The result, a closer look at Venus's volcanic landscape, which is as unforgiving as it gets. Then there are the gas giants, Jupiter and Saturn. These two are like the solar system's rock stars. In the 70s, NASA's Pioneer 10 became the first spacecraft to swing by Jupiter, followed by the legendary Voyager missions that gave us jaw-dropping images and data. Galileo, which orbited Jupiter from 1995 to 2003, took things to another level, showing us its moons in stunning detail, Io's lava-spewing volcanoes, Europa's icy crust hiding a possible ocean, mind-blowing. And let's not forget Saturn. The Cassini mission, which orbited the planet for over a decade, made sure we'll never look at Saturn's rings the same way again. It even sent a probe, Huygens, to land on Titan, Saturn's largest moon, revealing a world with rivers and lakes made of methane. Further out, we've got Uranus and Neptune, ice giants that don't get as much love as their closer siblings. Voyager 2 gave us our only up-close look at these distant planets in the 1980s. The data it sent back showed that even these far-off worlds are worth a second look. Uranus has a magnetic field that's all kinds of weird, and Neptune's moon Triton might be one of the coldest yet most intriguing places in the solar system. And while we're on the topic of not planets, let's talk asteroids and comets. These small but significant objects tell the story of how our solar system came to be. NASA's Near Shoemaker landed on the asteroid Eros in 2001, and Japan's Hayabusa missions brought back samples from Itokawa and Ryugu. OSIRIS-RX, meanwhile, made headlines by snatching pieces of Bennu, an asteroid with a slight chance of hitting Earth in the distant future. Comets have been just as captivating. Remember the European Space Agency's Rosetta mission? It not only orbited a comet but also dropped the Philae lander on its surface. Sure, the lander bounced around and ended up in a shady spot, but the mission still taught us a ton about these icy travelers. The Sun, though, is the real MVP of our solar system. Missions like the Parker Solar Probe are getting closer to it than we ever thought possible. Launched in 2018, the spacecraft is braving extreme heat to study solar winds and other phenomena that directly impact Earth. Meanwhile, SOHO, a collaboration between NASA and the European Space Agency, has been keeping an eye on the Sun since 1995, giving us constant updates on solar storms and flares. Then there's the hunt for life, real alien life. We're looking at places like Europa, one of Jupiter's moons, where a hidden ocean might harbor something swimming around in the dark. NASA's Europa Clipper, set to launch soon, will investigate this icy world. ESA's JUICE mission is already on its way to study Jupiter's other moons, including Ganymede, which also might have a salty ocean beneath its crust. These missions aren't just about finding microbes, they're about answering the age-old question of whether we're alone. Human exploration is heating up too. The Artemis program aims to return humans to the moon, not just to visit, but to stay, and use it as a launchpad for Mars. SpaceX is making waves with plans for interplanetary travel, pushing the idea that humans could one day be a multiplanetary species and pave the way for future space missions. The bottom line, exploring our solar system isn't just about gathering data, it's about dreaming bigger and pushing boundaries. Every mission, every discovery is a step toward a future where humans might not just live on Earth but thrive across the stars. The path is far from over. The question isn't whether we'll continue exploring, it's how far we're willing to go. The search for answers about space continues, and Mars rovers have found things about the red planet that no one expected. Rolling across Mars to find the truth, Mars rovers are like robotic explorers that have rolled across the dusty, rocky surface of Mars for decades. These fascinating machines have helped scientists figure out Mars' story, how it might have looked millions of years ago and how it's evolved into the planet we see today. Over the years, a handful of these wheeled robots have made the epic trip from Earth to Mars, each one loaded with tools to uncover new clues about the red planet. Let's talk about Sojourner. This little rover was NASA's first successful attempt at driving a robot on Mars back in 1997. On the 4th of July, Sojourner touched down in a place called Ars Vallis. Tiny and lightweight with just 6 wheels, Sojourner's job was to test if this kind of technology could work and collect some basic information about Mars. It carried a camera and an X-ray spectrometer to study Martian rocks and soil. Initially planned to last just 7 days, Sojourner surprised everyone by staying active for 83 days. It sent back pictures and data that laid the groundwork for future missions, showing us Mars like never before. Fast forward a few years, and we've got Spirit and Opportunity. These 2 rovers were part of NASA's Mars Exploration Rover mission and landed on opposite sides of the planet in 2004. Spirit touched down in Gusev crater, while Opportunity landed in Meridiani Planum, a region known for its flat plains. These rovers were expected to work for just 90 days, but here's the thing about these little robots, they refused to quit. Spirit kept rolling until 2010, and Opportunity held on until 2018, setting records for endurance on Mars. They found some game-changing evidence too, like minerals that form in water and signs of ancient lakes. This was a big deal because it meant that Mars wasn't always the dry, barren place we see today. Next came Curiosity in 2012. This rover was in a league of its own, bigger and loaded with advanced scientific gear. Curiosity landed in Gale Crater, a spot that scientists believed had a watery past. Curiosity has been exploring ever since, uncovering more evidence that Mars had freshwater lakes and even organic molecules. These molecules are a big clue because they could mean that Mars once had the right ingredients for life, even if it was just tiny microbes. Curiosity's discoveries have reshaped what we thought we knew about Mars, and it's still out there today, climbing hills and drilling into rocks. Then there's Perseverance, which landed in 2021 in Jezero Crater. This rover's mission is all about looking for signs of ancient life. It's collecting rock samples that might eventually come back to Earth for deeper analysis. Oh, and let's not forget Ingenuity, the tiny helicopter that came along for the ride. Ingenuity made history as the first aircraft to fly on another planet, which is just wild when you think about it. Perseverance is still busy exploring what used to be a river delta, giving scientists a better picture of Mars's watery past and what might have lived there. But it's not just NASA making moves on Mars. China's space agency joined the game with the Zhurong rover in 2021. Zhurong landed in Utopia Planitia, a massive plane on Mars. This marked a huge milestone, making China the second country to successfully operate a rover on Mars. Zhurong's mission has been about studying the planet's surface and looking below it too, using ground-penetrating radar. The data it's collecting adds even more pieces to the Mars question, helping scientists compare findings from different parts of the planet. Each rover mission has built on what came before it, pushing the boundaries of what we know about Mars, from discovering water-related minerals to finding hints of ancient lakes and signs that the planet might have once supported life. These robotic explorers have been essential. They're also paving the way for the day humans might finally set foot on Mars. The work they've done and continue to do has brought us closer to understanding not just Mars, but also how life might exist beyond Earth. But let's be real, getting to Mars isn't easy. Every mission is a gamble. The stakes are high, and the technology has to work perfectly across millions of miles. Just think about what it takes, launching a rocket, traveling for months through space, and then landing on a planet with an atmosphere that's barely there. It's no wonder so many attempts fail. But when it does work, the payoff is enormous. Each successful mission not only teaches us more about Mars but also shows what humans can achieve when we push the limits of what's possible. So as Perseverance keeps drilling and collecting samples, and Curiosity continues its trek, the story of Mars rovers is far from over. Who knows what the next generation of these robotic explorers will uncover? One thing's for sure, Mars isn't giving up all its secrets without